bunch of us are in your classroom. Are you not going to be in the classroom today?
Uh, who will not be in? Who will not be in today, this afternoon?
This is your classroom. We're all here in the hallway.
No, we have the class online. The course
Online.
is
Okay.
online.
It's all online, he said.
Wait, it's online?
All right, thanks for letting us know.
Okay, let's join online. If you want to sit in the class, no problem. But I am in Arizona. I am not in Oregon at all.
We're listening to you. We're all got to get our computers out and figure out how to get on Zoom. Might take a few minutes.
But the lab doesn't have any computers?
I don't know. I could let you know in a little bit once we get settled in.
No,
The
I
lab
mean,
doesn't have any computers, if that's what you're asking.
okay, because
Because I'm assuming you're on Wilsonville campus based off the picture from the
oh,
metro.
Yeah, we're
okay.
welcome to.
No, I'm in Phoenix, Arizona.
I'm talking to the student, Dr. Metwally.
Okay. I think we are ready now. Are you all set? The people who were at in the class, are you all back in?
Some of the students are still setting up.
Okay, we'll give them maybe 10 more minutes.
Okay.
Okay.
Looked like at least 12 people in the hallway. We currently only have 7 in the call.
Okay.
So that would be at least at least 11 more people likely added or sharing a computer.
Okay, so I'll give them 10 more minutes. Okay. Meanwhile, would you please look at my announcements? There is an announcement saying about the software that we're gonna use. Quartz 16.0 Lite, Lite. Please download and install while we are waiting. Stated in my announcement. Thank you. Bismillah. Oh. Oh. No. Oh. No. No. Allah. Bismillah.
Professor, so I'm trying to install the Cordis Lite that you are mentioning, and I'm having a bit of an issue. One, the link that provides you to, I should ask, are you there, first of all? Yeah, I guess we're waiting a bit. You guys can hear me, right?
Sorry, I was away.
Yep.
Would you please repeat your question?
We have a problem with the Cordis link. So it says to download Cordis Prime Lite 16.0.
Yes.
The link that you provided does not take us anywhere to the same page of what's listed in the document.
Okay. Forget about
gives
the
us-
link. Forget about the link. Search
Okay.
Quartz 16.0 Lite.
Okay,
Okay.
well, then I've done that. And the closest I get is a light edition down to version 17.0.
You couldn't find 16.0?
Not yet, no.
Is that what's on the SharePoint that you can download in the announcement?
Can you get it now? The SharePoint?
there is a file called Chorus Light 16-minute Windows Star in the SharePoint file.
Okay,
I'm gonna download it, but it's gonna take like 24 minutes.
take your time.
I found, yeah, my mic's on. I found a site that is printed on the FPGA that I'm putting it in the chat, and it's for Cordis 15.1, but it's for the DE10 Lite
You can use the one in the SharePoint.
in the SharePoint.
For you, yes.
Okay,
Daniel, if you want, I'll provide a link that gives you every version from 17.0 to 21.2. I think we're just trying to use 16 is from what I'm getting.
While we're waiting, Professor, just to confirm, all of the lectures are going to be remote? Are
Yes.
all of the labs going to be remote?
Everything will be remote.
Everything
As I
is
said,
remote.
I am in Arizona. I am not in
Okay, thank
Portland
you.
at all. I've just got an email from one of the students. He went to the room and he found it closed, so I directed him to join us online.
Thank you. Have a laptop? Yeah.
I believe we may start now. Welcome all to our class, and sorry for this confusion. And I will start sharing my screen. If we go to our shell on Canvas, we are going to see this. Here you may see the PowerPoints of all of my lectures. You may download it and follow up with me as I'm lecturing. I have here our lab assignments and some reading material that you may need. And those includes chapters EE 131 and EE 133, just few chapters from those that I think it will be very important to refresh your knowledge about them. If I go to assignments, you're going to see our homework assignments. It worth 50%. 3 lab assignments, 30%. And we have 4 quizzes. Each one will take 5%. So this is the total that we have. Now we go to announcement. Here, this one, this has the link to all lectures. Whenever I finish lecture or lab, it is recorded and I'll post it under this link. So, but it takes me a day or two to upload it. And the link to course. Here, the lab board, it is not, of course, in PV 274. This will be with Mr. Connor. This, he has your lab board. This for you to check out, you don't have to buy it. You just check it out. And by the end of the term, you will return it to Mr. Connor.
Who is Mr. Connor?
I'll send you his office number, okay, at Wilsonville, okay?
Is Mr. Connor on the Portland campus?
Yes, in Wilsonville, yes.
Okay.
Now let's go to our first lecture. Please download it so we can start. At your home screen, you are going to find the PowerPoint, all the PowerPoint lectures. This will be the first one. In this course, we have seen before in EE 131 combinational logic gates, and we knew how to realize a logic system using sum of product or product of sum, and we learned how we may reduce it using the Carnot map or any other technique. So we can get a compact combinational circuit that to represent a logical system. Then in 133, we moved from a synchronous system that's operating with no clock to a synchronous system that has a clock, and that started by knowing the flip-flops. Then we moved to counters, adders, and then we moved to many applications using this sequential logic system. So in this case, instead of building an adder using gates, no, there is a chip that can do the job. Why should I build an adder? Well, there is a chip that can do it. In any of those systems, if there is a change in the system, I have to rebuild the whole thing. Can you imagine you are making a production line that is packing Pepsi cans, and you are grouping them in 6 cans? What about if you want to group them in 12 cans? If we have sequential or combinational logic, I have to rewire the whole thing, make the design and rewire. But if we are using digital system with programmable logic devices, PLD, this is our course, Digital System Designs with High Description Language, HDL. I can change just one line and my system is up and running without rewiring, saving time, saving money. So it will lower the power requirement because I don't need so many gates to realize it. And of course, less board space. I have just one module. And if I want to test the system, it is much easier and simpler. And the reliability, of course, is much, much higher. And I have the flexibility to change and make changes very easily. Programmable logic software, we can use schematic to enter our circuit, or use the HDL, high description language. In this course, we are going to be learning HDL, and HDL has two major families. VHDL, very high speed integrated circuit hardware description language, and this is what we are going to use, or we may use Verilog. I think you might have seen Verilog briefly in electronic digital 1 and 2, 131 and 133. The board that we are going to use, it is one of the FPGA, Field Programmable Gate Array. Those are the main manufacturer of those. We are going to be using Altera, and there are series, different series within Altera, and the software we are going to be using Quartz, and developed by, and you can download it from altera.com. As I said, please review the chapters that I provided from EE 131 and 133. In our introduction, we are going to see the module structure, signals and constant, operators, combinational circuit. We are going to go through all of those this evening. As I said, we have two main families for HDL, VHDL and Verilog. We are going to be using VHDL, and it gives us modular design, top-down design methodology, and it is text-based. I just write my program. I type the program and that's it. This is how it would look like. Let me see the question. It is being recorded. One of you is asking about if this is being recorded. Yes, it is being recorded. It is recorded automatic. Now we are back to this slide. Would you please let me know what is the status of downloading the software?
Mine's installing at this point.
Mine's installed.
Installed. Okay.
Well, no, there are people who have it and people who don't.
Okay.
I've got about half a gigabyte left.
Is there anybody who is still downloading? Oh, Lewis, Cody. Okay. Let's continue while it is downloading, and hopefully it's not going to take a long time for installation. Okay. Here, if this is my program, I have here synthesizable constructs. Those are VHDL code that can be loaded to my integrated circuit on the board itself. And this code itself, it is linked with libraries that will have functions that are ready for me to use. So I have my code and my libraries. At the end, I synthesize it and download it to my board. For VHDL, we have data types, starting by a bit that can be 0 or 1. Boolean, this is logic, false or true. This is integer. It has a range. It can go from minus to plus. Minus 2 to the power 31 plus 2 to the power 31. Or it can be positive. Positive, that means the integer is passing by 0. That's why I have this minus 1. But if I don't pass the 0, because I am all positive, I will be starting at 1. Natural, it is positive again, no negative. But this one starts by 0. Real, this real one, it is a floating point. E to the power up to 38, 10 to the power 38. From minus e to the power 38 to plus e to the 1 plus times e to the power 38. It can be also characters. Our VHDL can handle characters, and it can handle also time. Time is integer quantity, and I specify what would be the units. Nanosecond, microsecond, millisecond, whatever you are going to use. In any program that you will be writing, I will start by saying I am going to use the IEEE library. And I need to say, out of this library, which package I will be using. I can use many packages. I can use many libraries, as a matter of fact. But here I'm going to be in our class using the IEEE library. And we may specify the packages out of this library that we'll be using. Then we have this part where I specify the input and outputs. A and B will be my inputs. C, for example, will be my output. And when I say A and B, I need to specify what type of data I'm using. So in this part, I specify the input and output and the type of the data. I may also give initial values for this data, for the input data. Then I go to the body of the programming part. It starts by the word architecture, and here is the end. Mainly, I have to have begin and this end. That's where I put my VHDL instructions. Those two parts are optional. Signals, we are going to speak about it in details. It is a connector between output and input. It can act as input or output. We have components. This component can do certain small jobs, as we're going to see. This is the general structure that we'll be using. First of all, we'll go through each part. Library, IEEE, those are the main packages of that library that we'll be using. And if we are using logic signals, standard logic signal, it can be uninitialized. This X unknown logic values, X can be 0, can be 1. We have 0 and 1. We say them, we call them strong. We are going to differentiate from weak. But this is the 0 and 1, you know it. This Z, it is a state that is high impedance. Sometimes I have output 0, I have output 1, or I may have output Z high impedance. High impedance means when I'm connected to the outside world, I'm having high impedance to prevent current from going in. The weak drive, here I have X01, I have WLH. What are the difference? Weak drives means they need a pull-up resistor. I need a resistor connected to high or connected to 5 volt or connected to 0 to have this function happening. X01, it is just I rely on whatever the output of my output port. That is how I declare my signal. The signal is here. Any signal, signal A, I specify here the signal A, it is a logic vector. Logic vector, that means I have 7 down to 0. It can be 16 down to 1, whatever you like. That means I have, for this one, 8 slots available for me to store data or to retrieve data from. I can have it with no vector. So it will be one variable. Here I'm giving initial values, all ones. This is another example. But here, can you see I am giving A5. And this small x denotes that we are speaking about hexadecimal. Hexadecimal, I am using 4 bits for each one. 5 has 4 bits. That is 1, 0, 1, 0. This is 5. A, another 4 bits. If I have a constant, I would declare it at the very beginning. I give it constant name. Type means integer or real. And if it is here, I should put the value this constant will be. Another example, this constant, I have here reserved 16 slots, 0 up to 15. That's why in hexadecimal, I gave it 4 digits. Each one is 4. So 4 times 4, it is 16. The operator, like any other language, I can use AND or NAND. I can use greater than for logical or relational operation, greater than, less than, not equal. I can have even shift operator, like shift register. I can rotate left, I can rotate right. This plus to add to numbers, this minus to subtract, and this one, it is concatenation. Concatenation, if I have 4 bits, that is A, and I wanna append to it another 4 bit, that is concatenation, to make 8 bits. Unary signs, that's plus or minus. Multiplication, division, modulus, remainder, and absolute or not absolute. We are going to be using most of those. Now, would you please let me know the status of your download? Are you done with the downloading and installation?
I'll go. So I've got it downloaded. I got it unzipped, but now it's installing.
Okay, that is
Yes,
close
sir.
enough. Before I go into programming language, I want to start using Quartz to build a circuit. And the circuit we are going to build, we are going to use the schematics, the schematic tools of Quartz to build this circuit. So I'll share the screen. Assignments. Would you please all go to assignments? Lab 1. This is where you are going to upload it. This is my home.
It's just,
I cannot.
quick question. The due dates.
Would you please unmute all the others? Just
I just had a
need
quick
one.
question for you. The due dates look like they're set a week or two early. Have you looked at those yet? There were some due dates set for last week.
And there's one that's due in 2
days.
days.
The due dates you are speaking about?
Correct. If you look in the calendar, there are some that were due last week.
And in
I will
December.
fix that. I will fix all of that. Which one? Those are my assignments. Homework 1 due January 21st.
Sorry, I guess those were meeting times that were the first week of the year, but the lab 1 looks like it's due this weekend.
2
Yep.
days, well, yeah, pretty soon.
As a matter of fact, we're gonna finish it this evening.
Okay.
Don't worry. Here we have lab 1. This lab 1, if you go through it, it tells you about what we need to do. It is about our FPGA. I need you to learn about it and read through the material and do the experiment in lab 1A. Okay? Now, that's all, just reading.
So there's 2 lab 1As. Do you want us to do the top one?
No, the one, it is reading. And here I have no, sorry. Those are the reading material. If I go through this, it takes me step by step in building a circuit that we are gonna be doing, and I am gonna show you an example right now. Those are the circuits. The first thing you need to do, if you go anywhere and you start making new
Professor, I hate to
folder-
interrupt, but it seems
Yes.
like some people are still installing the program.
Yes, I know. I know.
Okay.
I am saying here, I am making this subfolder test. Oh, let me call it N test. I got this folder and it is empty. And if I go to Quartz, I have 2 options: new project or open a project, existing project. Here I am going to be using new project. What is the working directory? I created my directory. It is under my document. And this is the name. Okay. What is the project name? It must be the same as the one of the folder. So it must be n-test. Next, it is empty project. I'm not adding any files at the moment. Next. Now I need, please write down these steps, or it is written in the handout. Don't worry. Written in the handout. This is, I need to select my board. And this is my device. If you look at the handout, you are going to see the same steps. You need to follow it. That's it. And it is FPGA, pin count 484 pins, and the core speed 7, and the filter is 10M50. Then M, not K. 10M50, yes. I take the first one. Next. Finish. Those steps will be the same for any program you are developing. Now we are ready. If I go here to new or file new, whatever you like, what kind of file do you need? If I need VHDL, I can use VHDL. If I need Verilog, I can select Verilog. Here I need block diagram schematic file. Here I have the screen for the block diagram schematic file. First, I need to add a gate. This is symbol tool. This is my library, primitive library. I need logic. I am looking for, let's take AND2. And with 2 input, and 3 will have 3 inputs. Okay. I place it somewhere here. I can add many more. To stop adding, escape. I hit escape. That's it. Okay. What will be next? I need input-output devices. Input-output connectors. Pin tools. This is input. This is 1. I need another one. because my AND gate requires 2. That's it, enough. Another pin, I need an output. Here is my output. So I have 2 inputs, 2 outputs, and I hit escape to stop adding any more. Now I need to reconnect or connect wire the AND to the input and the output. This is orthogonal node 2. I take from here drag up to here, another one, drag to here, and for the output, drag. I have the inputs and the output are all connected. I can change the pin name. Instead of pin name 1, I can use whatever you want. Double click and change the name. Before I proceed, I need to save this file. Save as. The default, can you see, and test. It is the same as the folder. It is the same as the project. And I will save it. After doing that, I need to make sure that this program is correct. So I need to compile it. Compiling, it is just processing, start compilation, or it is Control L, whatever you like. Now it is compiling, and if there is an error, it will stop and tell you the error. When is our next meeting? Hello?
Our next meeting,
Yes.
well, if the schedule is right, it's Saturday at like 11.
Okay.
For the lab.
Yeah, for the lab.
Okay. As a matter of fact, there is no difference between lecture and lab. I can use them interchangeably. Like now, I am giving you lab. And I gave you 1 hour ago, it was lecture. So we are using both of them.
Hello.
Okay, lab and lectures. Now I believe we are done with this one with no error messages. If I go here to messages, it will tell me what's happening. 0 error, 13 warnings. We don't care about warnings. We have this. If I want to get back to my schematic, this is my schematic. And this is my compilation report. Now I need to give it an input and get an output. To do that, I need new. The new file that I'm going to use it is the waveform viewer. The waveform viewer universe program viewer waveform. This is the one we're going to learn maybe in a week or two. Another methodology for seeing the input and the output, the interaction called test bench. But we are going to use extensively this waveform viewer. This waveform viewer, I have this screen. I need to set it up by going here to edit grid size. This is the grid size. I am going to say each block will be 100 nanosecond. Edit, set end time. What is your end time? We are still in nanosecond. I can say, let's go to 1000 nanosecond. I am here, 0 up to 1000 nanosecond, that is 1 microsecond. This is fourth setting. Now I need to get my inputs and outputs. I am going to insert them. I am going to grab them from the schematic that I generated. I generate the schematic, so I want to grab it. So insert node or buses. I'm going to use the node finder. The node finder, I am going to list all of my input and output. You can see in pin 1 and the other pin, and this is the output. I'll take them all. Okay. Okay. I have them here. 2 inputs, and the output here is unknown. I haven't made the run yet. Now let's go to the first one. I wanted to alternate between high and low. And this will change every 100 nanosecond, starting at 0. 0, 1, 0, 1, 0, 1, all the way. What about the second one? I wanted also to alternate between 0 and 1. But I'm gonna say it is gonna change every 200 nanosecond. This is the second one, 0, 0, 1, 1, 0, 0, 1, 1. Why did I select that? Because I have two inputs. Two inputs, if you remember the truth table, 0, 0, 0, 1, 1, 0, 1, 1, and repeating. Now, after doing that, again, I need to save. I need to give a name to this waveform. I will call it the same name. Now I am ready to the last step, simulation. Run functional simulation, run timing simulation. In timing simulation, it takes care of the rise time and the fall time and the processing time that happens within the logic circuit itself. If I have cascaded logic circuits, there might be a delay. And I want to see this delay, how it would affect. Would one of the signals come late and be considered by the following stage as high instead of low? In this case, I would use simulation, run timing simulation. But for now, I need just the functional simulation. Now it is checking. Here we are, our AND gate. Our AND gate. 0, 0 gives 0, 1, 0, 0, 0, 1, 0. Oh, here we have 1, 1. I will get 1. Hello, Brandon.
Hello,
How are you tonight?
doing good. How are you doing?
Just fine. How was your break?
Nice. How's
Very
yours?
short, wasn't it?
I guess.
Okay. Have you followed what I did?
Yeah, I'm doing the waveform setup right now.
Okay. Hello, Taylor.
Hi.
Have you made this program? You are
I'm
following
also
me?
on the, whoop, hold on, sorry.
There is an echo. I couldn't hear
Sorry
you.
about that. I'm at the waveform step too.
Okay.
Where, can you show me where that was again? How you got to that? I compiled it or, yeah, I finished the compilation, but I'm not sure where the waveform part is.
Okay. Joseph. Hello, Joe.
Hello.
Have you been following and have you built this circuit?
I'm still trying to install Quartus.
Have you installed it or not yet?
It says it's unpacking the files right now.
Is there somebody with you with another laptop?
Yeah, he just turned off his speaker.
Okay,
Just
just
leave it
just
normal
keep
in here.
one laptop running or unmuted, and the rest will be muted, just not to get echo.
Yeah, we did that.
Okay, how far you are from the finishing of the installation?
It looks like it's almost done.
Almost done.
Almost installing, yeah.
Okay, very good. So can you build the circuit as I did?
I mean, not right now, it's still installing, so I'll probably have to watch the YouTube video and try it again when I get home.
No, I'm gonna watch you when you are doing it right now. Start Quartus and share the screen,
No, my
and
Quartus
we'll
is not
all be
done
giving
installing
you direction. Whenever you finish, we are waiting
Okay.
for you.
Okay, yeah, I get it done.
You are installing right now.
Yeah, it's still installing.
Okay. We are waiting for Joe to finish installation, and he will do all the steps I did. If you feel comfortable with what I did, you may go to our lab assignment and start working on it. Let me share the screen. This is our lab assignment. Open schematic and use system tools. Every step that I did, it is in here. Generating or creating a folder. And we selected new project. We put here the directory and the name. And that is how we selected our board. All the numbers are in here. Then we started a new project and how we started adding our elements. Okay, so if you feel comfortable, or by all means, you can start with this because it takes you from zero until you finish building this circuit. It is AND, NAND, OR, NOR, XOR, NOT. A group of circuits.
Professor,
Yes, sir.
I'm trying to download the application, but every time I want to download it, it said, give me a product.
If you look at my announcement, if you look at here,
The announcements.
And we are sharing here the link also.
The Quartus installation.
Yes, there is. I have it on my drive, and I shared the drive link. And one of you has just posted right now in one of the messages the link to that drive, so you can download and install.
I see 2 words files, and I see just 1 file. So I have to download it from the file, right?
Here is our chat. In our chat, meeting chat, Taylor has shared the SharePoint where
Uh-huh.
you can download it. Go to the chat, and a message came from Taylor at 7:24. If you hit the link, you are gonna download the software.
Okay, thanks.
Thank you. But it takes time, maybe
Okay.
20-25 minutes.
Okay, cool.
You cannot download it? But the other students downloaded it today.
Are you actively logged in?
I cannot hear you, Taylor.
Are you actively logged in to the OIT system? I think you need to be like in that before you can access it.
Okay, okay, you need to log in with your OIT account, okay?
Professor, does the application support MacBook?
No,
Oh,
this is for Windows.
okay. I'll try to download it in my computer.
Okay. How is it going, Joe?
I think it just finished installing, so I'm gonna try to open up the software right now.
You are done with the installation?
I think so.
Okay, you may share the screen.
You might have to give me a minute. I wasn't prepared. I didn't bring my better laptop because I didn't know we were gonna be all online. I thought we were just gonna be in like classroom. So this might take a minute. I'm still waiting for the application to open up.
Okay.
So while we're waiting, is Connor Buckland the person we're supposed to meet up with?
Pardon me?
Is Connor Buckland the person we're supposed to meet up with?
I am gonna send you an announcement with the details of his office. Just a moment, let me look it
Okay.
up. Would you please check the announcement? You have all the contact info of Connor. Still in installation, Joe?
Well, I clicked to open Cordis software and I don't see it doing anything. It's just, I don't know if my computer that I have can handle it or something.
Is there anyone who has just finished the installation? Hello, Daniel?
Hello.
Do you
Yeah, I
have-
finished the installation,
You are done with the
Working on-
installation?
making the project, but I'm at the
You are-
EDA tools settings and
Okay.
following the lab.
Will you please start sharing the screen?
Yeah. Let's see.
Yeah, you have made already. You have selected already your subfolder.
Yeah, I made the folder.
Okay. So here you
Yeah.
are next. Nothing.
There's nothing on this.
Next.
Okay,
Next.
next.
Finish. Now we need a new project. Now it is starting.
Is it?
Yes, now we will need to go to File, New.
Oh,
You
and then we're
need-
doing a block diagram.
Yes, excellent.
I was paying attention.
Okay, now you go, yes. And you open this Altera primitive. You can
And
select whatever you want.
okay. And
Escape.
oh no, I pressed two of them.
Okay. You can hit it and hit delete.
Okay.
Yes, okay. Escape to get rid of it. Input. I believe you didn't get rid of the AND gate. Hit escape twice. Hit escape. Yes, now you can start getting the input.
Oh my god.
Select it and hit delete. Hit delete.
Okay, select and delete.
All of those wires, delete.
Okay. So weird. Maybe I need to make this bigger.
Maximize this.
Yep.
Leave it here, yes. And bring the AND escape. Escape to get rid of this. Escape.
Oh, escape. Here we go.
Move this, yes. And get the output.
And then an output.
Yes.
Go. And
Escape.
yep, there we go.
I'm
we
gonna stop guiding you and I leave it for any one of you to help him, okay? But I'm not gonna be guiding, I'm just watching.
Help.
We need,
Is it a line tool or a wire?
yes, this one.
It's the line tool.
No, would you all please help him?
Help! Someone help me! Oh my god.
So you should just be able, at least on mine, I was able to click on the input on the right-hand side of it, and then it changed the cursor. Yep, there it is. And then click and drag
Oh,
that to your animals.
oh,
There you
okay.
go.
There we go.
And release the mount. There you go.
Wow.
Ta-da.
Okay, and then here we want to save, I'm pretty sure. Unless there's something else I was supposed to do. Save? Save? Yeah, okay. And I have no idea where I'm supposed to go from here. Compile button. I know. Hard to see with all the Zoom start compilation. Yeah, why not? I don't remember this. Oh wait, compile design. I think I need to look at the next process is to compile the design. Right. So to share my screen and show everybody my struggle. Next step is okay, here's a compilation report. And then this. Yeah. Oh. It says, the next step is to sim object design. You will create a vector view file, waveform file, perform this step, and then run the simulator. Yeah. So it gave me the compilation report, and then run the simulation, and then RTL or gate levels. Gate. That's yeah. And function. Types of simulation. So they used RTL. For some reason, RTL wasn't working. For detailed simulation. So basic. I named the project basic data. Loaded links and report. But there's no way. This file. Hmm. That was it.
You skipped parts.
I skipped
The
the
way
part.
forward. The way forward.
So I compiled it.
After compiling, you need to generate a new file, waveform file.
Then it says the next step is to simulate the logic design. We will
Yes,
create a
It does,
vector.
it didn't tell you to go to simulate. It says we need vector waveform file. Go down,
Okay.
go down. Here. Go down, down. Down.
Oh.
Follow the steps from here.
Okay. Thank you.
Thank you.
This is what I've done.
Read slowly because don't rely on your memory. You are
Yeah.
gonna follow the instruction in here.
Primitives folder. I do that one too. We got the input and outputs. Open the other library folder and select the title symbol to enter lab information via the properties window. Open the other folder.
That is to select names.
So when they mean other folder,
Where is it? If I want to change pin name,
okay.
you double click on it. Now you can put the name you want.
Okay. Do they, and we're just gonna call it input one and input,
Yes,
A1 and,
Y1, whatever you like.
okay.
Here it says A1, okay.
Okay.
Then you see orthogonal node tool, number 8.
We can connect the pins to the various gates using the orthogonal node tool.
Yes. Are you all watching?
Orthogonal, so
Yeah.
tool.
Yes, you used it already. This orthogonal tool, you used it to make this connector between the input and the AND gate. Yes.
Professor Mithali, I have a question for you.
Yes.
And I'm trying to install it, and I got, Intel download the website now, and it's asking me like Quartus Prime Light 16 license renewal or 30-day evaluation license. Which one I
From
have to
where are
select?
you installing it? From the link I gave you? The link you have? You download it from the link I gave you?
Well, yes, I tried it, but it requires me permissions. You need permission to access this item.
As you have been listening to your colleagues, they said you need to log in with your OIT account, because I put it on OIT drive. So you have to be an OIT student to be able to download it.
Yes, I am. So, and I can.
And you are logging in. You are using your OIT account at this very moment, or you are using your private account?
OIT account.
Okay. Everybody else has succeeded in downloading it with the OIT account. If it doesn't, just log out and log in again. Or even restart your computer and log in with OIT account. It will give you the permission to download.
Okay.
This is to change the name. We are done with this. Go to the next.
So 12, double click on the title box.
That is to make
Select
some
file.
description. Forget about it for now. You can do
Okay.
it later on.
So file, save
Now
as.
we are at 18. We are finished with 18.
Okay.
18,
Yep.
19. We are done with all of 25.
Processing start compilation. So I did do that, but then I exited out of it.
Okay, we are done with compiling with no errors. Now we
Yeah.
are here. We are here.
Okay. And we're almost done. Oh, we're now ready to test the logic of the project.
Not almost done because you ran one gate. You still
Yeah,
have.
no.
And, okay.
It'll be smooth sailing after this.
Yes, everything will be smooth and easy. Yes.
Using the waveform editor. Okay, so we got to go back and then do the waveform. So file new. But I should save this first.
Here you are. Excellent.
Oh, really? Where is it?
Front desk.
Okay.
There's a lady doing it right now.
Oh, so I'll let everybody in our class know. They have all of the boards, the FPGAs down at the front desk for us to go pick up.
Okay. Excellent. Pick it up from the front desk.
Okay, waveform editor. File new, the waveform editor. Attach waveform editor. Save the file under the name. File. Save.
You guys gonna say?
Well, I'm kind of on the spot, so I got to.
No, basic data, enter, yes.
Okay. To run from 0 to 400. Edit end time. You man.
Can I jump in here for a second? Anybody on the Portland Metro campus, if you need the board, it's downstairs in the lobby for the next few minutes.
Oh, just a few minutes? I gotta go grab that before they close. Edit end time. Set end time, so 400 nanoseconds. Select view fid. Already fit.
You jumped something.
I jumped something?
Yes, the grid size. Last
Uh,
line.
Oh, yeah, the time period. Now select edit grid size. Edit grid size. Edit. This was 100 nanoseconds. There we go.
Professor,
Next, we want to include the input and output nodes of the circuit be
Professor
simulated.
Mutwalli,
Say that again.
Professor. Hello.
Hello?
Can Professor Amr Mutwalli hear me?
Yes, yes, sir. What do you want?
I downloaded the file from the announcements, and when I enter the file, it said run the setup. And when I run the setup, nothing happens.
You downloaded the file?
Yep. It said Windows cannot find.
You are using MacBook or
No,
Windows?
HP.
Huh?
Windows.
HP.
Did you extract it?
How can I do this?
It is zipped file. It is compact. You need to extract it. Are you reading, Mohammed? The messages, they are sending you messages.
I'm trying to extract it.
Okay.
Because I'm using my friend's laptop. You have to unzip the file.
Yes.
Do you have to download any application for unzipping?
If you don't have it, you have to download it, yes.
You shouldn't have to if you're on Windows.
No, we are done with this part. Come on, guy. Hey, no, we are done with this. We are done with this.
Oh, me?
You have it already. You are
Okay,
repeating yourself.
sorry.
There is when I click the right clicker, it said extract to a specified folder.
Yes,
That's it.
this is unzipping any file, any folder. Yes.
Okay.
We
So
are
I gotta-
done with all of those. Done. You haven't specified the input. You haven't specified the input. Read how to do it.
Evaluation. Click on A2. This highlights the signal and activates the vertical toolbar that allows us to shape the selected waveform. So it's highlighted.
Continue reading. Now you are not highlighting. You need to highlight again.
Okay, this highlights the signal and activates vertical toolbar that allows us to shape. Toolbar provides options such as setting the signal to 0, 1, unknown, high impedance, don't care, and inverted is existing.
Continue reading. Select node name A2.
Yep. Oh, did you get me one? Thanks, man. Okay. I'll let her know. Thanks, Joe. Select node name 2, set that the entire line for the signal is highlighted in blue. Assuming that this case, select an icon on the top toolbar that looks like that little guy. Count value icon. Selected, you should get a count value pop-up window. Count every 100 nanoseconds. Okay. Okay, and then this guy, there we go. Start value 0. Hey. Select node name A1, and we're going to do the same thing, but 200 nano. And click OK. You can connect your waveform file. It should now look like this.
Are you following those?
Say that again. Am I ready?
Read.
Oh, read?
Yes.
Yeah. Simplest way to test the functionality of your design is to assume that the logic elements and interconnection wires are perfect, thus causing no delay propagation of signals through the circuit. This is called a functional simulation. A more complex alternative is to take all propagation delays into account, which leads to timing simulation. We will perform only functional simulations in this class. Select simulation, run functional simulation. Okay, simulation, run functional simulation. Save. Should have saved first.
Congratulations. It is running or not? No, we don't have it running.
It's
Try
not,
it again.
not showing the output. Try it again.
Yeah. Is
No,
it still running?
hey, it's running.
Okay.
It's all gray.
Maybe it's still simulating.
Yeah, I'm at 0%.
Okay, let's wait.
Quit?
No, wait.
Oh, wait. Yeah.
Where is the screen where it was simulating and running?
It's just like these are grayed out so you can't click on them.
Because there is another thing that is going on. There is another screen
Oh. How'd that happen? Simulation waveform editor. Huh. That's weird.
Yes.
Should I exit out of
Function simulation.
should I exit out of the other one first?
No, no, just let it go.
Okay.
Are you sure about the names A1, A2, Y1? Have you changed any of those?
No.
Was it Y1?
Yeah, it was Y1 here. I'll go back to the schematic. Y1, A1, A2. Hmm.
And this was running, okay?
Yeah, this one, as far as like the
The compilation give no
Hey,
error, zero
Professor,
error.
what's going on? I still waiting for you to give me that install,
Give you what?
the install link.
So that might be.
It was given to you. You have the message. Look at the messages here. The messages that we exchanged today in our
Well,
Zoom.
yes, and you said I have to go log out and clock in back, and I did, and I've lost all of your messages. So that's why I'm asking you to send it me back.
You have my announcement. Go to announcement and you're gonna see it.
Okay.
Hey, Amar, I'm over here too. I can help him a little bit here and help him get sorted.
Okay.
Okay, I'll let me go there.
So, I hope you're not watching porn. Let's see. I gotta wash my hands now. Okay. So, announcements. Okay. So
0 errors, 15 warnings.
Don't worry
okay,
about
right
this.
here.
Okay.
Now go back and close all of these simulation waveforms.
Focus installation. All right.
And start a new one.
Okay.
Okay, this one.
So that one is the one you want. So download that, and then.
Okay, all right.
Cool.
Okay.
Sorry, man. I know you must come off night shift, right?
No, grid size. Edit the grid size.
Oh, yeah. Okay. Let's see. View.
No.
I'm gonna have to look back. Edit. What? Oh, grid size. There we go. Nanosecond.
This is not the grid size.
Yep, wrong one.
It shouldn't be 400. Yes, 100.
100. Oh, darn it. Oh my God. Grid. Yeah, it's supposed to be 100, right?
As it is written.
of 400 nanoseconds. Oh, the grid size is. Grid size 100 nanoseconds. 100 nanoseconds. Now we insert nodes.
What is this 400?
So I got to edit the end time and fit to window. Now we put in the pins. So A1 is the input.
No, it didn't say anything here. Cancel this. It says go to Node Finder. Edit. Go back to edit. Edit,
Okay.
insert.
Edit, insert.
Node or bus.
Oh, node finder. All right.
List.
Install.
Yes.
I'm supposed to move them all over, right?
Yes.
Okay. That's probably what I didn't do last time.
Did you say okay? Okay.
There we go. Okay. Now okay, now I gotta set time change. Oh. What am I doing? Oh yeah, it was the C button up here. There we go. This one was 100.
Go to simulation.
Functional simulation. Save.
Give it name.
Okay. Hey. Oh man. So now I got to do this for all the other logic gates.
Excellent.
Okay. Awesome. Thank you.
You need to read very carefully the handout and follow it to the letter.
Yeah. So once it's simulating and it's ran the output, I've already saved, so I can just exit out of this.
Yeah, all what I need is a snapshot of the program itself and a snapshot of the waveform.
Okay. But by the end of the lab, this is gonna be full of all the different gates, right?
Yes, of course.
Okay, I see.
Read the handout. It gives you a sample of how it would look like.
Perfect.
Would you please stop the sharing of the screen?
Yeah. Thanks again.
Thank you. Hello, Joseph. Hello, Joe.
Yes, I'm still here.
How far are you? You are done with the installation?
Yeah, I got the installation done. I opened up Quartus finally. I'm making the schematic right now on the, what's it called? The schematic file, design file.
Yeah.
I'm getting there. Just computer's a lot slower than what I wanted it to be.
Okay.
Yep. But I was watching the video.
Okay. Cody, how's it going? Cody?
Well, I got it downloaded, but then I couldn't follow along, so I just did what I did out of the lab work, the write-up, and got a little ways on there, but that's about it.
But you haven't installed it yet?
I haven't installed, and I followed some of the first steps for the lab thing that we're working on.
Excellent, excellent. Kobe?
Yeah, I have it installed. I am almost done with the one sheet of lab we've been working off of.
Yeah. But it is installed already now?
Yes.
Okay. Mohammed?
Yep.
Installed?
No, not yet. I'll go
Still
to
unzipping?
I'll go to the IT tomorrow to help me with downloading the application.
Okay. Okay. Please make sure before Saturday you are done with this lab.
Yeah, for sure, no problem. I'll go tomorrow to fix it, and I'll do it tomorrow. You will download this video tomorrow, right?
Yes, as soon as we finish, it takes time as soon for processing, then uploading to YouTube.
Cool.
Whenever it is done, I will have it available for you. Hopefully by tomorrow. I'll do my best to be by tomorrow. You have it ready.
Thank you.
Professor Elmer, I have a question for you. I've just downloaded that install and wondering how to open it because it asked me, you know, what program I have to start with. So what did you do at this point? And I was expecting it's automatically attacks itself, but it says what you want to open this file, and I have only two options. Adobe Reader, obviously it's not the one. So which one is that? Is that VM Web? Is that the one? Which one is that?
Could anybody help him who have finished installation? Would you share the screen?
Okay, let me do that. All right, do you see that? Quartus Lite 16.211.
This needs to be extracted. This is a zip file, tar file. It needs to be extracted first.
Okay,
So-
then I can open it.
This-
Okay, install it.
If you go to like 7-zip, you can download an extractor file and then just right click on it to extract using 7-zip.
7-zip, it's I have to download from
Yeah,
Google, right?
yeah,
Okay.
just type 7-zip in Google and it'll pop up.
All right then. All right, thank you. Let me try that.
Does anyone need any, or do you have any questions about this lab part?
I was just wondering, how long will you be uploading this video right away?
As I said, it takes time to finish compiling and processing, then I upload it. So hopefully by tomorrow I will.
Thank you.
Thank you. We may say good night at this moment. And on Saturday, we are going to continue, but we are not going to continue lab part B, but we are going to go to our VHDL programming. We are done with this logic gate simulation using the schematic. Now we are going to target our main objective is VHDL programming, and that will be done on Saturday morning. Okay?
To confirm, did you say we are not doing part B of lab one?
Not part B tonight.
Oh, okay, on Saturday.
Not tonight. But
Okay.
on Saturday, I have to teach you VHDL. Then we can go to part B.
Okay, sounds like a plan.
Okay, so on Saturday, we are going to be learning VHDL and we'll be doing the homework. Then, along with the homework, we're going to be doing Lab 1B because all of those are VHDL programs.
Professor,
Yes.
are we meeting all the labs and lectures via Zoom?
Would you please repeat the question? I could understand it.
Are we meeting always in Zoom link?
As I said, I live in Phoenix, Arizona. This is my only way to communicate with you.
Because in the website it said that it is an in-person class.
I believe they intended to have the class available for you just in case somebody doesn't have the proper camera or somebody who doesn't have a computer that can install this course. So, or if you wanna meet together and work on a group project, this room will be open for you.
Uh-huh,
I
cool.
believe that was the intention.
Cool. Thank you. So
Our
we'll meet.
our meetings will be online,
Okay.
but
Cool.
the class will be available for you if you wanna get together, make a study group, whatever you like.
Cool. Thank you. It is the same for the 335, right?
What is 355?
It is the same for the 335 class.
Any class I teach is online.
Okay. Thanks.
Thank you. Any other questions?
Yeah.
You may have said I just missed it. Is it 11 a.m. Saturday?
Yes,
Okay, thank you.
11 a.m. Saturday. Please make sure that you are done with lab 1A. Lab 1A. Thank you all. I wish you a great evening and see you Saturday then. Bye now.
Have a good evening,
Have a
everybody.
good evening.
You too. Bye bye.